All right, so this is going to be the part C of chapter 23. So the last part. So the last part, last portion process in urine formation is water conservation. And so in water conservation, we're simply moving the water out of the renal tubule and moving it back into, okay, what happened here? So that's what we're seeing down here. We move it out of the renal tubules, mostly the collecting ducts, but it can happen through the other tubules and moving it back into either the vasa recta or paratubular capillaries. Now, this is part of what we call the counter current multiplier. And that's what we see here. The material is going to move this way down the renal tubule, and it's going to become more concentrated. And then it's going to go up towards the cortex and become less concentrated. And then it comes down the collecting duct and becomes more concentrated. So counter current, down, going into, it becomes more concentrated, going up, it's going to become less concentrated. Down becomes more concentrated. Comparing, and this unit is called milliosmoles per liter, and that's a concentration of fluids. So again, we call this the counter current multiplier. As part of the concentrating urine. So it goes in one direction, but the quantity of solutes is going to be in the opposite direction. Down, it goes up, it goes down, it goes up again. If we go back to this diagram, again, you see the 4 urine processes. And so if we look at what's in the renal tubule versus what is in the bloodstream, all right, so I can get this up here. Glomerular filtration, we're moving materials into the renal tubules. Glomerular or tubular reabsorption, we're moving it back into the bloodstream. Tubular secretion, we're going back into the renal tubules. And water conservation, going back into the bloodstream. So it's a give and take. So blood versus nephron. Glomerular filtration, you're going from blood to nephron. Tubular reabsorption, you're going back into blood. Tubular secretion, you're going back into the nephron. Tubular secretion, and water conservation, you're putting it back into the blood. Okay, so the product at the end that gets dumped into the minor calyx is called urine. So composition and properties of urine. Color. It typically ranges from colorless to deep amber. The yellow comes from urochrome. Urochrome is a breakdown product of hemoglobin. So it's one of those pigments that's generated when we break down hemoglobin. Okay, urochrome. Now, there are foods, there are drugs, and there are disease processes that can alter the color of urine. So, drugs can make urine orange, purple, blue, black. Foods, consuming too many beets can make the urine pink. Consuming too much spinach can turn the urine green. Metabolic processes. There is a lipid metabolism problem that causes the urine to be white, like milk. There's dumping all the lipids in, and so that causes the white appearance of urine. Another attribute, urine is supposed to be transparent or clear, not cloudy. Cloudy could be an accumulation of cells due to a urinary tract infection. Cloudy could be some other type of bacterial infection. So it could be a lot of things but it should be transparent or clear. Odor should have a distinct but not offensive odor. The longer it stands or sits, it's going to have a stronger and stronger ammonia smell. Again, there are some foods and disease processes that can cause differences in the odor. The consumption of asparagus causes a distinct odor. Some types of coffee can cause a distinct odor. There is a metabolic disorder where the body cannot handle a certain amino acid called phenylketonuria, and that causes a mousy odor to the urine. Other properties, osmolarity can range from 50 milliosmoles per liter in a dehydrated person, or 50 milliosmoles per liter in a well-hydrated person, up to that 1200 milliosmoles, which is very concentrated. So if you're well hydrated, you have less concentrated urine. It also tends to be lighter in color. If it's more concentrated, that means you need to drink more water. And yes, drinking more water is going to make you make more urine, but that is a good thing, not a bad one. pH can range anywhere from 4.5 to 8.2 on the pH scale. Typically, we try and keep it at 6.0, or at least on the acid side, so on the lower end. That helps to keep the urinary tract, especially the urinary bladder, limiting the bacteria and yeast productions. So that's a defense mechanism there. At a lower pH, bacteria can't survive, and neither can yeast. Chemical composition, even though we pulled out as much as we can, 95% of it is going to be water. The rest of it is solutes. So here are those nitrogenous wastes we mentioned way back in the blood chapter: urea, uric acid, ammonia, and creatinine. Those were the four most numerous nitrogenous wastes that we talked about at the beginning of the chapter. Sodium ions, potassium ions, calcium ion, chloride ions, and bilirubin. Bilirubin can be expelled both in feces and urine. Normal volume is 1 to 2 liters per day. So even though we filter out 150 to 180 liters, those other three processes are going to reduce that to 1 to 2 liters per day. Again, if you change your volume of consumption, that's going to alter your urine formation. If you don't drink much, then your urine formation is going to drop off, and it's going to be very potent. It's going to be very concentrated. The more water you drink, the better off you are, because you can flush out excess water. Okay. The word diabetes is often misused. The word means excessive urine formation or polyuria of a metabolic nature. It's not because you just decided to start drinking more water. The name and symptom is found in two different disease processes. And each disease process is associated with a different hormone that you have too much of, or deficiency. Sorry, not too much of, you're deficient in. Diabetes mellitus is a condition caused by not enough insulin. Diabetes mellitus can be classified as type 1, type 2, type 3, and gestational diabetes mellitus. So with type 1, it's typically the body doesn't make enough insulin. You're born that way. Type 2 is something that's typically acquired because of overconsumption of carbohydrates. And so the body has to overproduce insulin, and so it gets worn out. Type 3 is associated with Alzheimer's disease, and it's a deficiency associated with the brain stopping the messages going to the pancreas. Gestational diabetes mellitus is associated with pregnancy, because mom's body now has to process not only her carbohydrate consumption, she also has to process babies. Diabetes insipidus is a condition where you don't have enough antidiuretic hormone. So the pituitary gland is messed up. The body is constantly on a diuretic. So it's always getting rid of water instead of holding on to it. The antidiuretic hormone helps you reduce water loss. And if you don't have enough of it, you're going to continuously produce urine and lose the water. Okay, so that's the kidneys. Once we have urine, because we're animals, we want to expel it. All right, ureters, tubes with the same 3 layers as the minor and major calyces and renal pelvis. So again, transitional epithelium. The middle layer is smooth muscle and elastic tissues and dense tissue. They empty into the dorsal inferior wall of the urinary bladder. Oops. So way down here. That way we fill the urinary bladder from the bottom up and we don't cause damage. So the tubes may look like they end here, but they go behind the urinary bladder and empty in at the bottom. You have different mechanisms for moving urine from the kidneys down into the urinary bladder. You have gravity, because in us, the kidneys are superior to the urinary bladder. You have peristalsis, because the smooth muscle tissue and elastic tissue are going to propel the urine because it stretches the tubes. It's going to respond by being myogenic and propel it along the tube. And then because of hydrostatic pressure. So we keep making urine, you keep dumping it in there. Okay, urinary bladder, same 3 layers of tissue. However, this has a different shape, much wider, and it has a much thicker layer of smooth muscle tissue. So thick that it's called the detrusor muscle. It's going to relax as the urinary bladder fills up, and then it contracts to empty it. Again, the ureters are going to empty into the inferior dorsal wall. There's also an internal sphincter at the base of the urinary bladder. It's a thick ring of smooth muscle tissue. This smooth muscle tissue works in opposition to the detrusor muscle. So as the urinary bladder is filling, the detrusor muscle is going to relax. The internal sphincter is going to contract. When a certain volume is reached, there's impulses that are going to be sent to cause the detrusor muscle to contract and the internal sphincter to relax. And that's what we feel as the need to empty the urinary bladder. Now, another pet peeve of mine, soapbox, I guess. In adults, in mature nervous systems, the need to empty the urinary bladder is going to wake you up in the middle of the night. So 99 or 95% of bedwetting in children is because they sleep too deeply. It doesn't wake them up. No, there's not a magical age where they're going to start waking up. It's their nervous system that has to mature. Also, most people that have a stroke lose that awareness, regardless of where the stroke occurs. They lose that awareness of when the urinary bladder is full. Okay. The urethra, different in both genders. The male urethra, again, same layers of tissues, but it's fairly long It passes through the prostate gland, which is just inferior to the urinary bladder, and it passes through the length of the penis. So, not only does the urethra transport urine in males, it also transports semen. So it'll also be part of the reproductive tract. In the urogenital diaphragm, there is an external sphincter as opposed to the internal sphincter. Let me get rid of some of this. So in the urogenital diaphragm, there's an external sphincter, which is a thick ring of skeletal muscle, as opposed to the internal sphincter, which is smooth muscle tissue. That has to relax in order to allow urine to pass through. In the female, the internal sphincter, same place. The urethra is much shorter. Your external sphincter is in that urogenital diaphragm, but they're much closer together. In the female human and other primates, the urethra only transports urine. In primates, and including humans, the urethra has its own external opening in the body. In a lot of other mammals and other vertebrates, the urethra empties into the vaginal canal. So there's only one external opening or orifice for urine and the birth canal. But in humans and other primates, you have two separate tracts. So, micturition. This is a video that you need to watch. There's some others that I didn't include in the PowerPoint, but they're on the list for the chapter. But again, in Anatomy and Physiology Revealed, micturition reflex is emptying the urinary bladder. You also have this picture, but I think I'm going to stay with this one. As the urinary bladder fills up, when it reaches somewhere between 150 and 250 milliliters, it's going to start sending messages because you have baroreceptors in the detrusor muscle. It's constantly sending impulses to the sacral portion of the spinal cord. That sends messages back telling the detrusor muscle to contract and the internal sphincter to relax. That's our perception that we need to empty the urinary bladder. We have to send messages back to the external sphincter so that it contracts until we can get someplace appropriate to empty our urinary bladder. Then we're going to relax that so that the urine can pass out. If you ignore the micturition reflex, the urinary bladder is going to continue to fill. Again, you'll get more impulses as the volume increases. As more tension is created, you get more impulses indicating, so as long as you have muscle tone in the skeletal muscle of the urogenital diaphragm and that external sphincter, you can wait. When you lose muscle control or muscle tone, then it's going to come out. So it comes out more, the urge or the need to empty the urinary bladder is going to become more urgent. But you have to have muscle tone, control of that skeletal muscle in order to prevent urine from seeping out. Now, this picture does highlight that portion of the sacral spinal cord where you have the reflex center, including a parasympathetic ganglion, since this is a parasympathetic response. You do get input from the pons, interpreting the impulses, passing it on to the hypothalamus for your feelings of, oh, I need to empty the urinary bladder. Now, if you're at this point, you're going to be in pain because those baroreceptors are stretched out beyond what they should be. Incontinence is typically we lose that sensation or awareness, or we lose muscle tone in the external sphincter, meaning we can't control that. A leading cause of incontinence as people age is obesity. It stretches out that urogenital diaphragm, including the external sphincter. Also, multiple pregnancies. So that would not affect men, but women and pregnancies. So the stretching out because of the pregnancy can also weaken that wall. Doing Kegels exercises. Oops. Kegels exercises is contracting the urogenital diaphragm. It's an exercise you can do and nobody knows you're doing it, I guess, unless you're having intercourse or coitus. And that's another thing. Because the urogenital diaphragm is also anchored to the orifice of the vaginal canal, it also increases muscle tone there. So Kegels exercise can help reduce incontinence, both in men and women. And then it can also increase muscle tone in the vaginal canal. So micturition, emptying the urinary bladder. Now, this is an antiquated version of hemodialysis. If your kidneys aren't working, you'll have to have artificial filtration. So, like I said, this is antiquated. They haven't used this in like 15, 20 years. Currently, the shunt, which is what we see here, is in one blood vessel and it's underneath the skin. And that's to reduce infection and reduce damaging the blood vessels. The dialysis tubing is in a cylinder, which is a single individual use, and it's filled with hundreds of teeny tiny little straws rather than this long tubes. Either way, on one side of the tubes is going, or in the tubes is going to be the blood, and then outside of the tube is where they put the dialysis fluid, and that's basically going to be a normal saline, sometimes with extra electrolytes. But anyway, it's not going to have the waste products that the blood's going to have. And so as the blood passes through, the waste products are going to get dumped out and pulled out of the body. Now, this is a process that can take 2 to 8 hours, and you can sometimes have to do it 2 to 5 times a week. And that's why you see dialysis centers out in the shopping centers, out in various neighborhoods, because that way people don't have to travel all the way to a hospital. So they've taken that out of hospitals for the most part and let you go to these dialysis centers so you can have a less invaded life because your kidneys aren't working. A second type of dialysis is called periantal. And rather than using this tubing and opening things up, you actually use the wall of the abdomen as a filter. It's 24 hours a day, continuous. You change out the fluid every, I think it's 8 hours is what it used to be. But basically, you have the blood on one side of the abdominal wall, and then you have the dialysis fluid on the other. Less effective, and that's where, if your kidneys are really bad, you need a kidney transplant. Okay, urinary system. That will be the end of part C for chapter 23. Okay.